In this example, we're dealing with a sample space of 36 elements. We know that because we're rolling 2 die. Each die has 6 possible outcomes, so that's 6 times 6 by our counting principles, or 36 possible outcomes. The outcomes for event A are basically on the diagonal, and the outcomes for B are in the upper left corner, as you can see based on the colors that I used. So the probability of A here is 6, those 6 elements on the diagonal out of the 36 possible outcomes in the sample space. The probability of B in this case is 16 over 36 because there's 16 elements in that upper left corner that satisfy B out of the 36 possible outcomes. We can also deal with the complements. The probability of A complement is everything not included in A. So there are those 6 elements on the diagonal in A, which means there are 30 elements that are not in A out of the 36 possible outcomes. Same thing with B complement. There are 16 elements in B, which means there are 20 elements not in B. So the probability of B complement is 20 over 36. We can also combine events with ands, with an and or with an or. So if we say the probability of A and B, that means in order to satisfy the event A and B, it must satisfy both events A and B, just as it says. So there are only 2 elements that are in both A and B out of the 36 possible elements in the sample space. We can also say A or B. We can combine events with an or. To satisfy the or, they must satisfy A or B or both. This is where you have to be a little careful. You just can't take the elements in A, which is 6, and add the elements in B, which is 16, because that gives you 22. But you're counting the elements in the overlap twice if you do that. So you got to be careful there. There's 16 elements in B, plus the 6 elements in A, but you don't want to count those 2 twice, so you only take those additional 4 from A, which gives you a total of 20 elements in A or B out of the 36 possible outcomes. And then the last type of probability is the conditional probability. We have the probability of A given B, and it does matter what order this is written in. Probability of A given B is different than the probability of B given A, and I'll do both of those. The probability of A given B means given that B has occurred, what's the probability of A? This is the one case where our denominator is changed because we're given B has occurred. So we're only dealing with the 16 elements in B. That is now my denominator. Out of those 16 elements in B, how many satisfy A? Well, it's basically that overlap or those 2 elements. If we switch this around and say what's the probability of B given A, then my denominator, since I'm giving A, is the number of elements in A, which in this case is 6. And we want the number of elements in A that also satisfy B, which is, of course, those same 2. So the probability of B given A, in this case, is 2 over 6. So we can also use our rules to solve some of these probabilities. So like in number 3, we have the probability of A complement. We can use the table, but we can also use the complement rule, which says this is equal to 1 minus the probability of A, because everything in A and everything not in A makes up the total sample space, which has to give you a total of 1. If you think about that, that should make some sense. In this case, the probability of A was 6 over 36. So if we take 1 minus 6 over 36, or basically 36 over 36 minus 6 over 36, then that gives us 30 over 36, which is exactly what we said the complement of A should be. We can also use the addition rule. We'll use it for number 6, where we found the probability of A or B. Probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. And sometimes these rules are easier than actually looking at the table. If you think about this rule, it should make some sense as to why it works. The probability of A or B equals the probability of A plus the probability of B, but remember, you can't just add those 2 things together, because if you do, you're counting the overlap twice. So basically what you're doing when you subtract out the probability of A and B is you're subtracting out that overlap. So in this case, the probability of A is 6 over 36. The probability of B is 16 over 36, but then we're subtracting out those 2 elements that are in both, so we don't count them twice. and that gives us our 20 over 36, which is what we said the probability of A or B should be. We can also use the conditional probability rule. The probability of A given B, that equals the probability of A and B over the probability of B. This one's not quite as nice and neat just to think about, but if you plug in some probabilities, you can kind of make some sense of it. The probability of A and B is 2 over 36. And if we divide that by the probability of B, which is 16 over 36, then we'll get the probability of A given B. So here we have a complex fraction. So hopefully you remember how to deal with these. This is 2 over 36. And dividing by a fraction is the same as multiplying by its reciprocal. So we can multiply by 36 over 16. If you'll notice what happens here, the 36's cancel, which is the denominator from the original probabilities. Those denominators cancel, and that's always going to be the case because remember, those denominators are always going to be the number of elements in the sample space. So think about what that leaves you with. The numerator is always going to be however many elements are in the overlap. The denominator is always going to be however many elements are in the condition, which is exactly what you want in a conditional probability. A given B means you're limiting yourself to that condition, so you want the denominator to be the number of elements in the condition, which in this case is the 16. And out of those 16, you want the number of elements that are in B that are also in A, or you want that overlap, which is 2. So you get that probability of 2 over 16. And all of these rules will always work, and they will save you some time. If you know these probabilities, if you know, for example, in the addition rule, any 3 of those probabilities, you can always solve for the 4th one.